Hi class, this is the video for 4.3. We're going to be talking about differentials and linear approximations in this video. And so what a differential is a differential refers to the tangent line. So the differential of x, which we're going to call dx, okay, that's the difference in the horizontal distance of the tangent line at a given place. And same thing for y. A differential of y is the vertical distance, the vertical change in the tangent line from a given point to point. Okay, and so what we're going to use to find, we're going to be asked to find the differential of y. This is our formula for that. Okay, so the differential of y, remember f prime of our slope, that's the slope. So this is like the equation of the tangent line basically. The change in y equals our slope times the change in x of our differential equation. Okay. All right, so, and here again in words, kind of what that means. So delta y represent the change in height of the graph of f. dy is the change in height of the tangent line, okay? So delta y, we've seen that before when we're finding slope. Change in y is another way to think about that. Dy is still a change in y, but it's with regards to the tangent line. So here's kind of a picture to illustrate some of that as well, where this is our tangent line and this is my function f. Okay, so these are the kinds of problems we're going to see with regards to differentials. Okay, so we're going to be asked to, well, first, this is something not new. Find an equation of the tangent line to the graph of f at 0, 0. So we are going to find f prime of x, okay, to get our slope of the tangent line. I'm going to use the product rule here. So derivative of x is 1. Plus x times derivative of e to the x is still e to the x. Okay, so f prime of x is equal to, I could factor out the e to the x and say it is this guy. And then at 0, 0, so if I plug in 0 for x, we get e to the 0 times 1 plus 0. So 1 times 1 is 1. So our slope of the tangent line at 0 is 1. So we're going to say the equation of the line then is y minus our y coordinate equals our slope times x minus the x coordinate. That does simplify down into just y equals x. Okay, now here we're asked to find the differential dy. So this is where I'm going to use this equation to help us out. So it says dy is equal to f prime of x. So f prime we just got was right here. So we have e to the x times 1 plus x times dx, okay? And our change dx is our change in x. I'm actually just going to write it as dx right now. Okay, so this is kind of the equation I'm going to use to find the differential. So now we're asked to compare dy to delta y. So remember, this has to do with the tangent. This has to do with the actual function. Okay, so they're both changes in the vertical height, but we are referring to the tangent line versus the slope. So basically we're asking like how far off is the tangent line of the actual function. Okay, so and we're asking what happens when we change from 0 to 0.5. Okay, so let's start with dy. So again, I'm going to use this function. So dx is the change in x. So from 0 to 0.5, my change is 0.5. So I'm going to do e to the 0 times 1 plus 0 times the change in x, which is 0.5. So 0 to 0.5. So this is the dx. It's the change in x here. Okay, so if I simplify that, so I get 1 times 0.5 is 0.5. Okay, now what would I have gotten if I did just change in y? So the change in y is f of 0.5 minus f of 0, right? So this is the second y value, this is the first y value, so that would give me the change in height for the actual function. So if I do that, so f of 0.5, so I'm going back to my original function, this guy, and I plug in 0.5, so I've got 0.5 times e to the 0.5, right, minus 0 times e to the 0. So this whole part's going to be 0. So 0.5 times e to the 0.5, I'm going to put that in my calculator. 0.5 times e, and I'm going to put this in parentheses actually, e raised to the 0.5 I'm gonna round 3 decimal places here, so we got 0.824. Okay, so now when it says compare, it's like, what's the difference between these? So if I were to subtract those, I would get a difference of 0.234. So the tangent line is 0.234 less than our actual function at this point. So we're going to say the tangent line is 0.324 below the graph of f at x equals 0.5. So when I change from 0 to 0.5, that's kind of the change in our y values. Okay, this for the actual function, this for the tangent line. Okay, so we're gonna do the same thing, but we're gonna pick some different x values. So the first part, same thing, we'll find dy. So we're gonna plug in x is 0. And then our change in x, so from here to here, the change is 0.1. Okay, so again, this all just happens to be 1, so 1 times 0.1 is 0.1. So our dy is 0.1. Delta y, same thing, I'm doing f of 0.1 minus f of 0. So we already know from up above, f of 0 is just 0, so I really just need to find this. So f of 0.1 is, original function again is x times e to the x, so 0.1, e to the 0.1. Again, I'm going to put that, and then minus 0 is what that other one turns into. Okay, so put that in our calculator. So I'm just going to change these guys to 0.1s. We get 0.111 if I round to the nearest thousandth. Okay, and again, if I look at, and I'm trying to compare, so again, this is less than this one by 0.11. So the tangent line is, 0.011 below the graph of f at x equals 0.1. Okay, so this one's closer, right? 0.5 is still pretty close, but this one got even closer as my x values are closer together. Okay, now we're asked to do the same thing, but this time I have an even smaller change in x. I've got 0.01. So we're going to say dy again is e to the 0, 1 plus 0, times our change in x from 0 to 0.01 is that, which is just going to give us 0.01. And then delta y is f of 0.01 minus f of 0. Again, we recall from before, f of 0 is just equal to 0. So this guy turns into 0.01 e to the 0.01. Okay, plug that in our calculator. I'm going to grab this one again. And I'm going to insert some zeros. Oh, and I did it in the wrong spot. There we go. Okay. All right, so we got 0.0101. I'm going to go 4 decimal places just so it's different than this one. 0.101. Okay, so this is 1/10,000th different than this. So these are really, really close. But the tangent line is just slightly below by a matter of 0.0001 below the graph of f at x equals 0.01. So you guys can see the closer that delta x gets to 0, so the closer these two numbers are together, the better approximation the tangent line is. Okay, so that's what we're going to put here for interpret results. The closer dx, right, so the change in x, this value, the closer that is to 0, the closer dy is to delta y. Okay, so in other words, the tangent line becomes a much closer approximation for f of x, okay, if dx is close to 0. All right.